Hello everyone, welcome to this video on nucleophilic substitution reaction SN1 and SN2. So this presentation I have mostly taken the notes from the content from Clayden book. So let's start. So introduction to nucleophilic substitution. So what does nucleophilic substitution mean? So a nucleophile replaces a living group on sp3 hybridized carbon. So these reactions are of two types, that is SN1 and SN2. So SN1 reaction is nucleophilic substitution unimolecular and SN2 reaction is nucleophilic substitution bimolecular. So this SN1 reaction forms an carbocation intermediate and this rate depend on the concentration of the only substrate. In this, it depends on both substrate and the nucleophile. So it is a bimolecular reaction. So this image says that as we go from primary, secondary, and tertiary, the increasing rate of SN1 reaction is observed. So tertiary is more favored in SN1 reaction, and it is a just opposite in SN2 reaction. So in SN2 reaction, the primary is more favored than secondary than tertiary. So these are the mechanism of SN1 and SN2 reaction. So in SN1 reaction, the living group, that is Cl, will leave and it will form an carbocation, and then nucleophile will attack and it forms an desired product. So in SN2 reaction, the nucleophile will attack from backside and the living group will leave. So we get a desired product. So these are example I can say of SN1 mechanism, reaction of tertiary butyl bromide with hydroxide ion. So here the bromide, this will leave bromine, and this is a slow step, and the carbocation will form. Then nucleophile will attack the carbocation. This reaction, this step is fast, and here we get a desired product. So this is a two-step reaction, that is SN1, and SN2 is one-step reaction, that is concerted. Both the steps are going back to back. So this is in this SN1, the tertiary is more preferred as we have seen because it forms an carbocation. So carbocation, tertiary carbocation is more stable than secondary than primary. So in this reaction SN2, the tertiary is not favored as when the nucleophile will attack, these groups are bulky. The steric hindrance factor plays an important role here. So that's why the attack is more hindered. So the living group will be not much easier to leave because this reaction is concerted. So when we see in primary carbocation in this, so this is unhindered. Okay, these groups are not much bulkier than this. So SN2 reaction, this primary, that halide carbocation is more stable than secondary than tertiary. So this is a comparison of SN1 and SN2 reaction. So SN1 is unimolecular substrate only. It depends on substrate only rate of the reaction. It is a bimolecular rate depends on substrate and nucleophile. So big barrier is carbocation stability and steric hindrance. So as we have seen here, the carbocation stability in SN1 is more, that is tertiary is more favored. And in SN2, the steric hindrance, so this is more sterically hindered. So the attack is not that much stable. So here it is not hindered because protons are there. Okay. Then same that we have seen, the nucleophile here it is weak and strong. The solvent, that is polar protic solvent, that is water and alcohol, is used in SN1, and SN2 polar aprotic, that is DMSO and acetone is used. The stereochemistry here, retention and inversion is observed, that is racemization both 50-50%, and here only inversion is observed. So these are my handwritten notes I felt to just put. So this is a mechanism as we have seen. The bromine will leave, carbocation will form and give both retention and inversion product, and it is called an racemization reaction, that is SN1 reaction. SN2 reaction. So here the only inversion product is obtained. So these are the questions that you guys can solve and drop the answer in the comment if anything is wrong or any queries. So thank you for watching the video. I hope this video helped you to understand SN1 and SN2 completely. So this was a basic SN1 and SN2, that is a core concept needed in the organic chemistry. So see you in the next one. Bye bye.